Power grid modernization is a process of upgrading and improving the existing power grid infrastructure to make it more efficient, reliable, and sustainable. The power grid is a complex network of power plants, transmission lines, substations, and distribution systems that deliver electricity from the power source to the end users. The modernization of the power grid is necessary to meet the increasing demand for electricity, integrate renewable energy sources, and improve the overall performance of the power system. The modernization of the power grid is necessary to meet the growing demand for electricity, improve the reliability and resiliency of the system, and reduce the environmental impact of power generation. Grid of today does not have the attributes necessary to meet the demands and opportunities of tomorrow. 6 key trends challenging the capacity of the grid are driving this transformation: changing types and characteristics of electric generation, growing demands for a more resilient, reliable, and cyber-secure grid, growing supply-side and demand-side opportunities for customers to participate in electricity markets, emerging electricity information and control systems, and aging electricity infrastructure. Advancement in grid protection schemes. The traditional grid architecture is based on large-scale generation remotely located from consumers, hierarchical control structures with minimal feedback, limited energy storage, and passive loads. A modern grid must have greater resilience to hazards of all type, improved reliability for everyday operations, enhanced security from an increasing and evolving number of threats, additional affordability to maintain our economic prosperity, superior flexibility to respond to the variability and uncertainty of conditions at one or more timescales, including a range of energy futures, and increased sustainability through additional clean energy and energy-efficient resources. Further includes the installation of smart meters, advanced sensors, and automation systems that allow for better monitoring and control of the power grid. The modernization of the power grid is necessary to meet the growing demand for electricity, improve the reliability and resiliency of the system, and reduce the environmental impact of power generation. Modernization efforts also involve the integration of renewable energy sources such as solar and wind power into the power grid system. This requires the development of new technologies and infrastructure to support the distribution and storage of renewable energy. Key components. The power grid modernization involves several key components, including the integration of advanced technologies, the development of new infrastructure, the adoption of new policies and regulations, and the involvement of various stakeholders. See these components in detail. Integration of advanced technologies. One of the key components of power grid modernization is the installation of smart meters. Smart meters are advanced devices that measure and record the amount of electricity consumed by individual households and businesses. These meters allow for more accurate billing and can help consumers better understand their energy usage patterns. Smart meters also enable utilities to remotely monitor and control the flow of electricity, which can help prevent power outages and reduce the need for manual meter reading. Another important aspect of power grid modernization is the deployment of advanced sensors and automation systems. These technologies allow utilities to monitor the health of the power grid in real time and quickly identify and respond to any issues that arise. For example, sensors can detect changes in voltage or current levels, which can indicate a potential problem with the power grid. Automation systems can then take action to isolate the problem and prevent it from spreading to other parts of the grid. The integration of advanced technologies is one of the key components of power grid modernization. Advanced technologies such as smart grids, energy storage systems, and advanced metering infrastructure (AMI) can help to improve the efficiency, reliability, and sustainability of the power grid. Smart grids are intelligent power grids that use advanced sensors, communication networks, and software to monitor and control the flow of electricity in real time. Smart grids can help to reduce energy consumption, improve the reliability of the power system, and integrate renewable energy sources. Energy storage systems are devices that store excess energy generated by renewable energy sources such as solar and wind power. Energy storage systems can help to improve the reliability of the power system, reduce the need for expensive peaking power plants, and provide backup power during outages. Overall Advanced Metering Infrastructure (AMI) is a system that uses smart meters to collect and transmit data about energy consumption and production. AMI can help to improve the accuracy of billing, reduce energy consumption, and provide real-time information about the performance of the power system. Smart grid technologies are made possible by two-way communication technologies, control systems, and computer processing. These advanced technologies include advanced sensors known as phasor measurement units PMUs, WAMS, WAMPAC, SPSRAS, that allow operators to assess grid stability, advanced digital meters that give consumers better information and automatically report outages, relays that sense and recover from faults in the substation automatically, automated feeder switches that reroute power around problems, and batteries that store excess energy and make it available later to the grid to meet customer demand. Development of new infrastructure. The development of new infrastructure is another key component of power grid modernization. New infrastructure such as transmission lines, substations, and distribution systems can help to improve the efficiency, reliability, and sustainability of the power system. Transmission lines are high-voltage power lines that transport electricity from the power source to the distribution system. The development of new transmission lines can help to reduce energy losses, improve the reliability of the power system, and enable the integration of renewable energy sources. Substations are facilities that transform the voltage of electricity from high to low or vice versa. The development of new substations can help to improve the efficiency of the power system, reduce energy losses, and improve the reliability of the power system. Distribution systems are networks of power lines that deliver electricity from the substation to the end users. The development of new distribution systems can help to improve the reliability of the power system, reduce energy losses, and enable the integration of renewable energy sources. A smart energy management system is a computer-based system that monitors, controls, measures, and optimizes energy usage in a building, factory, or any other type of facility. The systems can link electricity-consuming structures, such as HVAC, lighting, and machine tools, with meters, detectors, and other devices that can monitor measures and integrate information structurally. Moreover, these devices have the ability to communicate with the utility or the grid operator to time interactions, such as energy purchases during cheaper off-peak hours. Participation in demand response events, and EV-managed charging stations. This makes improved energy management systems a prime example of smart grid solutions aimed at efficiency. Adoption of new policies and regulations. The adoption of new policies and regulations is another key component of power grid modernization. New policies and regulations can help to promote the adoption of advanced technologies, encourage the development of new infrastructure, and ensure the sustainability of the power system. Policies such as Renewable Portfolio Standards (RPS) and Feed-in Tariffs (FIT) can help to promote the adoption of renewable energy sources. RPS require utilities to generate a certain percentage of their electricity from renewable sources, while FIT provide incentives for the production of renewable energy. Regulations such as net metering and interconnection standards can help to promote the adoption of distributed energy resources (DER). Net metering allows customers with solar panels or other DER to sell excess energy back to the grid, while interconnection standards ensure that DER can be safely and reliably connected to the power system. Involvement of various stakeholders. The involvement of various stakeholders is another key component of power grid modernization. The power grid is a complex system that involves various stakeholders such as utilities, regulators, policymakers, consumers, and technology providers. The involvement of these stakeholders is necessary to ensure the success of power grid modernization. Utilities are responsible for the operation and maintenance of the power system. Utilities can help to promote the adoption of advanced technologies, develop new infrastructure, and comply with new policies and regulations. Regulators are responsible for overseeing the operation of the power system and ensuring that utilities comply with regulations. Regulators can help to promote the adoption of advanced technologies, develop new infrastructure, and ensure the sustainability of the power system. Policymakers are responsible for developing policies and regulations that promote the adoption of advanced technologies, encourage the development of new infrastructure, and ensure the sustainability of the power system. Consumers are the end users of the power system. Consumers can help to reduce energy consumption, adopt renewable energy sources, and provide feedback on the performance of the power system. Technology providers are responsible for developing and supplying advanced technologies such as smart grids, energy storage systems, and AMI. Technology providers can help to improve the efficiency, reliability, and sustainability of the power system. Power grid modernization is a complex and ongoing process that involves collaboration between government agencies, utility companies, and technology providers to ensure a reliable and sustainable energy future. While the modernization of the power grid presents significant challenges, it also offers tremendous opportunities to improve the efficiency, reliability, and sustainability of our energy systems. The future grid will solve the challenges of seamlessly integrating conventional and renewable sources, storage, and central and distributed generation. It will provide a critical platform for all-world prosperity, competitiveness, and innovation in a global clean energy economy. It will deliver resilient, reliable, secure, affordable, flexible, and sustainable electricity to consumers where they want it, when they want it, how they want it. Power grid modernization is vital for utilities to improve reliability and resilience, reducing the impact of outages and disruptions. It enables better integration of renewable energy sources like wind and solar, making the grid more sustainable. Modern grids increase efficiency by using smart meters and sensors to optimize energy flow and reduce losses. Demand response programs and smart grids help balance supply and demand, cutting costs during peak usage. Additionally, modernization supports electric vehicle EV adoption and energy storage systems. It also enhances cybersecurity to protect against growing threats and provides real-time data for better decision-making, ensuring a future-ready energy infrastructure.